Hello, today we're making a video game. We're gonna make Breakout. Very simple game, shouldn't be too hard to do. But this whole video series, follow along, should serve as sort of a second step in our Unity learning journey. So we've done a little bit, we've learned about prefabs, we've done a little bit of scripting, maybe used a get component, done the roll a ball tutorial, and then how we go from making small little components that do one thing into actually putting together like a video game that can manage multiple things, having some kind of manager, maybe a score. That's a sort of a trickier thing, and that's what our focus is in this video. So this video, part one, we're just gonna do the mechanics of Brick Breaker. We're gonna have a paddle that moves, a ball that bounces, and bricks that can get hit. And then in the second and third videos, we'll get more into the what I think are the interesting parts of the video, which are that okay, I have all the pieces of a game, but how do I make it like playable and have a game loop? But before we do that, we need a video game. So let's make Breakout or Brick Breaker. You got a paddle at the bottom of the screen. You move it left and right. Steve Wozniak would be proud. One thing that I learned about apparently the arcade cabinet version, where did it say this? The arcade cabinet used a black and white screen and put cellophane over the bricks, over on the screen to make them look colored, which I think that's fun. That's not relevant here, but that's fun. Anyway, if you don't know who Steve Wozniak is, give it a Google. My favorite Brick Breaker game is the one that came with the Blackberries, because my dad had a Blackberry, and I would steal it. And it had this little thumb wheel thing, this little spinny wheel. And it was a really good input device. I didn't think this at the time, but thinking back, like compared to like left and right arrows or like a teeny little joystick or something, it had like momentum. You could like spin it to the side, and it would there was like a little bit of haptics in there or something. I have fond memories of like being at like an airport and being like bored out of my minds and being like, "Dad, give me your phone. I want to play Brick Breaker." Let's get started with our game. I have a new empty Unity project. This is a 2D project, just in the 2D template. And 2D versus 3D gives us a few advantages. The default scene, as we can see here, has no directional light. The background is not a skybox. It is a solid color there. And if we bring images into the project, they will get imported as sprites and not textures. And we have a couple of packages. The one that we're going to use is sort of this sprite setup. Because I don't want to make sprites. I don't feel like that. We just need some squares. Well, Unity's got some squares for us. Good to go. All right, so where do we even get started? Well, we make a list. But I've already done all that, so you can just follow along. That's the whole point of this video. So we're going to make paddle movement. We're going to make the ball. We're going to make the boundaries of the screen so the ball can hit that. And then we're going to make a block that we can break. And that's all we're doing in this video. So let's start with the paddle and paddle movement. We're going to start with a new, in the hierarchy, I'm going to make a new 2D object. And then under sprites, because I'm in that 2D template on a modern version of Unity, I should see 2D object, sprite, and square. If you don't see that, hopefully you're in a version of Unity. They've added this somewhat recently. Version of Unity, where with that 2D package, you get these sort of preset sprites. Otherwise, make a square. It's a white square. The resolution doesn't matter. I think this one's like 512 by 512 on the default. Anyway, so we have a square, and that will work for us for now. We'll put it on the bottom of the screen, and we will, we'll do, just put the X as 0, just center it perfectly, whatever. And now we need to figure out how we're going to move it left and right. And our gut instinct might be to give it a rigid body. And in fact, that is what we're going to do. But I want to make a point that that's not what we don't need to do it that way. I just want this example to be a bit more flexible and something you could take and steal and use for something else or something unrelated. We definitely don't need a rigid body to do movement in a game as simple as Brick Breaker. But we're going to on our sprite renderer. Let's give it a rigid body 2D. We're in the 2D template. We got to be very careful that we have the 2D version of the rigid body. And let's give it a box collider 2D. And I'll name this to paddle while I'm at it. We can stretch it out on the Y, X, flatten on the Y or something like that. And if we hit play, we're ready to play brick breaker. We can't move yet. Oh, and we fall. So the rigid body, we'll go ahead and set our gravity scale to 0. But one thing you may notice, other than gravity scale, is these constraints. We're going to want to check those. I'm going to leave them unchecked for now, but we're going to set up the physics system to not even let us move up and down or rotate. I'll uncheck them to show you what that's going to do when we get a ball in the scene. First, let's make our first script. Of course, we're going to make a folder called scripts to organize it, capital S. Plural, we always stay nice and organized. And we're going to make a new C# script. And I'm going to call this one paddle movement. And that's going to be with a capital P, capital M. We're going to capitalize every word, no spaces. And when we do that, because remember that our file names for our scripts need to match the class names for our file. And now we've got this fun, I don't know, I think it's fun. We got this nice default script that gives us the start and the update loop already. Just like the rollerball tutorial, we want to get a reference to the rigid body, because if we're going to use the rigid body to move, we're going to need to store a reference to that somewhere. We have this component right here, this one, and I need to save that so I can talk to it and use all of its features and functions. So saving a reference is something that should make us think variable. So let's make a private rigid body 2D. And I'm going to call this one rigid body 2D. I have a little underscore here. That's because my IDE JetBrains is doing a lot of autocompletes for me. I love using autocompletes. It's one of the best things about C# and modern C# development is just how well integrated the editors, the IDEs are to making our life easier for us. For example, our next step is going to be doing a get component call and start. And I can just like, look at that, I generated it. But let me show you what we're doing. We're using the get component function. Get component function here. We have these angle brackets that are we have to put a type in. Rigid body 2D. And then this is still a function, so we still need to give it those parentheses, even though we're not taking any arguments. This is going to return a value. So let's set it equal to our variable, or set our variable equal to the value that this function will give us. And how could I forget a semicolon? We love the semicolon. Okay. So now we have a reference to this variable. We do it in start. As you remember, the first start happens before any update code. So now we can start to use it. We need to get input from the player. We need to get input. So let's make a quick float. Let's call it movement. And let's set it equal to a function that we can get from the input class, the old input system, as it's lovingly or unlovingly called, input.getAxis. The getAxis function has a bunch of predefined axes that we could change and rename and do whatever we want. We're going to use one that's here by default called horizontal. And then how do we plug this in? Well, we could maybe set the velocity directly. We could add a force left or right like we did in rollerball, or we could move it directly. Now we're going to do that last one, but first let me show you the velocity one. We'll set our velocity equal to a new vector 2. What do you want? Roger by dot velocity. What do you vector 2 or vector 3? Vector 2. Of course, physics 2D. We're simplifying all of our math. And x will be movement and y will be 0. See these little x colons? That's not, I didn't type that. That's actually just here from JetBrains writer. So this is just vector 2 parentheses, movement comma 0 parentheses. So that this little y colon thing, that's not actually there. That's just a little preview. If I take my paddle movement and drop it on my paddle, I hopefully should be able to move. A and D, left and right arrow keys, left and right on a joystick as well, all supported right here out of the box. Love to see it. I'm not moving very fast, am I? So we're not going to use velocity. Instead, we're going to use a function built into the physics system called move position. which we're just going to give it a new position in world space, and it's just going to move us there. And if our rigid body is dynamic, whatever that means, then it will calculate collisions on the way. And that's great. Unfortunately, if we do that in the update loop, everything starts to break. So we need to use a new Unity event function called fixed update. And this is going to happen once per physics tick as opposed to once per frame. Because physics generally happens slower than frames. We do it at a fixed interval every, I don't know, 20 times a second, 50 times a second, whatever the default is. I don't remember. But update happens as fast as it can. So having things happen as fast as they can, if there's a slower frame, maybe a bunch of complicated things are happening, that frame will take a little bit longer. You know, you get like a jitter maybe. That can super throw off all the physics calculations, trying to correct for all that inconsistency. So we have the physics loop happens just at a set time interval, which is one of the reasons this is a performant and efficient physics system, is it doesn't have to do a lot of that math. Anyway, so we have a separate update loop for physics. So we're going to use that rigid body 2D.move position function. We need to give it some position in world space, but this variable over here, I can't access it over there because I created the variable in update, and that's not what I want. So we're going to need to move this around. So we're going to need to make a new variable that exists outside of the fixed update or the update loop, just in our class, and then we will set its value in update and read it in fixed update. And it will be a float as before, and we'll call it input. Sure. There we go. Now, if I forget to remove this, that'll mess us up because we're making a new variable. It'll ignore this one. It'll use the one in that scope. If I get rid of that float, oh yeah, well, okay, I'll use this one up here. So when we're making multiple variables, as we refactor and organize code and we give them the same name, easy way to cause bugs in our code. So we got to be careful to pay attention to specifically which variable is getting referenced inside of our curly braces. All right, so now we need to give it a position somewhere, and we'll start by giving it its current position. And rigid body 2D actually holds a reference. We could use transform.position, and that should be fine. Honestly, that would be fine. But we're going to use the one that's stored in the physics system just to make sure that like it's the same as the one that it's going to be using for all of its math in fixed update, with moving it with the rigid body, even though those positions should match. Okay, so here we're moving it to our current position, so we don't actually move it anywhere. We need to offset its position by some amount. So I'm going to make a variable called delta just so I can keep my code off of having one really long line that'll go off the edge of the screen. But you can type this part just right here, which is a vector 2 delta, and it will be some amount of x, like movement, and some amount of y, 0. We don't want to move. We don't want to move up and down. So I have some small difference. When this is 0 and 0, well, our current position plus 0, hey, don't move. So that should be fine. So let's see what this does. Let's see if this works. We're definitely missing a few steps. Some of you know what those steps are and are like, oh, what's going on? Oh, I'm moving way too fast. I'm moving way too fast. I'm flying off the edge of the screen. What's happening is I need to normalize this value for, because moving one entire unit every physics tick, that's way too much. So I need to normalize this value by the amount of time that has passed since the previous physics tick. Because if a different amount of time passes, which the physics tick doesn't want it to, but there can be small variations, I want to make sure I normalize against that it is, you know, if the physics tick takes a little bit longer or the update loop takes a little bit shorter, or physics tick takes a little bit shorter, that it will move me the same amount. I won't suddenly jump just because my frame rate jumped. Again, because we're in fixed update, it's like usually not as big of an issue, but like that doesn't mean we write our code wrong or bad. Let's do it the right way. So we have to do that. Great. Okay, so we can move to a new position, which is our current position, plus some offset, and that offset is ultimately driven by our input. And I should be moving nice and slow again, at 1 unit per second abouts. Let's see, where's my unit? Here's my unit. One, yeah, it's 2 of these lines. Those might not be on the video. So from here to here, I believe is 1 unit. So let's say if that's going to take a second. Maybe, I don't know. Anyway, it's slow. So let's make it fast. Let's make a public variable. Let's call it float. Let's call it speed. Sorry, let's give it the type float and let's call it speed. And let's multiply our code here, movement times delta time times speed. That's going to be the number that we want. And then if I go back into Unity and I hit play, I can't move. Nope, can't move. What's happening? Well, my speed's set to 0, and anything times 0 is 0. Set that to 10, and there we go. Huzzah! There is a problem, which is that I can move right out the edge of this, off the edge of the screen. Oops. I made that change in play mode. We'll set that down. Let's set that to 20. Let's go faster. I can move right off the edge of the screen. So I can just keep going. That stinks. Well, we know because we're going to have the ball bouncing off the edge of the screen that we're going to have a collider. We're going to have a physics collider on the edges of the screen. And because we're using our rigid body for movement, and we're using this move position setup, we should be able to sort of borrow that collider to stop the paddle moving as well, which is why we're doing it this way. Keeps things a little bit simple. We don't need to write any logic like, okay, if X is less than this number, then don't let me move left, but let me move right. And kind of complicated. Not that complicated, but might as well let Unity do it for us. So I'm going to make a square, and I'm going to give it a box collider, not a 3D one, a 2D box collider, and I'm going to call this boundary left. And we'll set its Y to like 10 or something. And I'm going to leave this visible just to test to see, does our paddle stop moving? It does. But as you notice, there's something, we got a little bit, just a teeny little bit of rotation. Teeny little bit of rotation. And we want this to be nice and perfect. And then the other reason we don't want to allow for rotation, if I just real quick drop a... if we just real quick drop a sphere into the scene and it falls, it'll cause our paddle to spin. And then that's not quite what we want. So let's go to our paddle. Let's go to the rigid body 2D settings, and let's constrain it to not let it rotate and not let it move on Y. But we can still use its regular physics collisions with the edge of the screen to stop it. It has a little bit of this like bounce as it resolves the collision, and I kind of like that. Just a little bit of a bounce. I kind of like it. So there we go. This is a nice and flexible movement system that we can use. So we're sort of setting our velocity and moving it ourselves, but we're not using velocity and having to deal with a lot of its complications. We're just saying, okay, move here. And that's nice. So now we got to get these boundaries set up. And as I move my scene view around, the boundary's wrong. I want to go over here. So to fix that, we're just, in the meantime, going to decide that this is going to be a 16:9 game. And as I move my scene view or my game view, it's going to be locked in on its coordinates. So we can put that there. And then as I rescale, it's not going to move on me. And then I will duplicate that, move it over to this side. And we'll call this one boundary right. Now, eventually I'll get that like perfectly off at the edge of the pixel perfect, but I'm leaving them visible here just for me to like remember that they're there. Might as well make a boundary top that the ball will bounce against. Something like that. something like that. But that's fine. Okay. I'll make a new empty game object. We'll call it boundaries, and we'll put its position at 0, 0, 0. And then I will grab these boundaries, put them in the boundaries object, like a little folder here to organize them, hide those out of the way. And we can turn them all off and on at the same time, which is nice. We're not going to have one below us because the ball's going to go that way. We've got input here right inside of the same code that does movement. I don't love that. Because if we want to change this to a Pong game, now I'm making paddle movement bottom and paddle movement top, and I've got like player 1 and player 2 inputs, but otherwise the code's identical, and that's copying and pasting code. I don't like that. I want to separate my input from my movement, and then I can write a second player or an AI, or I can, turn input on and off, in like a loading or menu thing, and this code doesn't get so complicated. But that's a later refactor for a later me. For now, that's fine. Let's make the ball, and let's make it bouncy. So we'll start with the 2D object, a sprite, a circle, and that's a ball. A little big. 0.2, 0.2 on the scale. I don't know. Pick a scale you like. Make it bigger. I don't care. And let's add a circle collider, 2D. Remember, 2D physics. And let's add a rigid body, 2D. And let's, it's got gravity on it, so it should fall. Brick Breaker. What a great game. So we need to make it bouncy because it hit our paddle and it stopped moving, and that's bad. So I'm going to create a new folder. I'm going to call it game data, I guess. I don't know. I kind of like organizing all my settings files in a different place, in a subfolder. Inside game data, we'll make the actual folder I want, which is going to be physics materials, like a material, but for the physics system. And then you'll see that there is a physics material, but this is for the 3D physics system. We want to go up into the 2D menu and find physics material 2D and create that. And we're going to call this bouncy. A physics material is just a little object that has 2 float values that it saves, and that's all it has. It's just a little convenient way to store these 2 numbers. One of the numbers is friction, one of the numbers is bounciness. These are numbers that we put between 0 and 1, where 0 is none of this property and 1 is like 100% of this property. We're going to have no friction and 100% bounciness. And that bounciness is sort of the percentage of energy that comes back. If I drop a ball and it hits the floor and that bounciness is 0.7, it will go 70% the way back up to its original position. So in that bounciness, I can choose to add it to a circle collider 2D component or to the rigid body. And the question is like, which one of these matters? Which one of these is the one that matters? Well, if we hover our mouse over them, we can see that the one on the rigid body overrides the global settings. It overrides the default. But the one on the collider overrides any rigid body 2D or global settings. So the answer is Unity is going to tell us which one of these matters. It's the one on the collider that's important. So let's make sure we can put it there. And then we wouldn't put it on the actual, you might think, oh, just add it to all of them. But that might throw us for a loop, because if I'm editing my code and I try to change it, and then I put a different physics material here, and then nothing changes. And I'm like, what's going on? So I don't like leaving things that I know won't do anything in my game, because then I might forget that they don't do anything and try to make a change, and it's easier to make mistakes and have bugs. So let's try it with the paddle and the ball, and it's bouncy. Amazing. Let's go to our boundaries, select, and select all of them, and then I'm going to click on this little select bullseye thing and give all of those that bouncy material as well. But we don't want it to have gravity. So I need to turn gravity off to 0, and Brick Breaker, what a game. Okay, so we need to move the ball. How should that work? Well, if we look at a reference and how it works, the BlackBerry Breakout game has the ball start here, and then you can kind of aim and then shoot it off in a different direction. That's not what we want. I'm too lazy to do that. I don't feel like doing that at all. You can do that. Go ahead. I won't stop you. Instead, we're just going to have it like appear somewhere and then fire off in a random direction. That's good enough for me. So let's rename this game object to ball. And on our ball, let's make a new script. Let's create a C# script. Let's call it ball. I know, I'm really breaking the mold with this one. And this ball will be on the ball and it'll control the ball. Great. We need to fire in a random direction. We need some kind of function that can do that. So I'm going to write a function that is very optimistically named. Fire in random direction. Whoops, forgot the return type. It doesn't return anything, so return type is void. And it will do this in start. We need to get a random direction and then apply it to the rigid body. Okay, so I don't know how to get a random direction, but I think I know how to do this part. We could set the velocity to some random vector, or we could add a force to the thing. So let's go ahead and get a reference to our rigid body 2D component, just like we did in the paddle. That's going to be a private rigid body 2D. And then in start, we'll do the get component, square bracket, same type, square bracket, parentheses. And we make sure we want to do that before this, because if I do this after, that's bad, because this will be null, this will be empty until we call this function. This is going to be empty, and then if we try to use it, it won't work. So to deal with those sort of what we call race conditions of which happens before what, there is another function that Unity will call for us called awake, and it's just like start, except it will call awake on all of the game objects before it calls start on any game objects. So I like to move get component calls into awake, and then in start I can do whatever I want, and I'm confident that the any code up in awake has happened. So maybe a game manager perhaps is going to call this function from somewhere else in its start script, and I don't know if the ball is going to get start or the game manager is going to get start first. I have no idea. It's going through the hierarchy, calling them on all the objects. I should be able to reorder things and organize it how I please, and that could break my game. I could make a build, it could be different. We can just assume that the order that it happens is random and write our code to be able to handle that. And we do that by using awake, which happens before start. Okay, so get a random direction. That's a vector 2. Random direction. Great. Well, let's just type random and see what we got. A bunch of things are popping up, but let's take an actual look at the scripting API of the random class and see what kind of functions it has. The one we use the most often is random.range, some value between a minimum and a maximum that we give it. But there are some other ones. Inside unit circle, picks a random point inside or on a circle with a radius of 1. That looks good to me. We should maybe use that one. Inside unit sphere, same thing in 3D. On unit sphere, on the surface, a random rotation that might be useful, if we're thinking of converting that into a vector, and so on. So we're going to use this inside unit circle, which is a vector 2, and every time we ask for this number, it's just going to be a different random value. That value could be very small or it could be very big. Well, it won't be very big. It'll have a radius somewhere between 0 and 1. The vector will have a magnitude somewhere between 0 and 1. But let's just see what happens if I take my rigid body and I set the velocity to that direction. So we know that it might be very slow, but will it do anything? Let's just test. Did we put the code on the ball? No, we did not. We put the ball on the ball. Ball needs a ball script. Okay, let's try again. Yeah. Oh yeah, now it's exciting. Heck yeah. Okay, let's make it go faster. Um, let's make a float. Let's call it launch speed. Why am I making, let's make a public float. Why am I making a public variable instead of just, multiplying this by some number? And the answer is because I don't know what this, I have no idea if it's how fast it should be. I don't know what a good number is. And if I make it public so that I can edit it here in the inspector, 100,000. Then it's just that's a designer problem. We can just change it and play with it and fiddle with it and test it. And that's our code. We shouldn't have like these design challenges hard coded into our game. So we take this random direction, multiply it by our launch speed. We still have a problem, which it still might be very slow because this is going to be some inside the unit circle that it could be very small. To get away with that, or to fix that, we're going to use the normalize function. I already used that word a bit. Normalize returns this vector with a magnitude of 1. So if it's a very short vector, it will lengthen it until it is 1 unit long. If it's a very long vector, it will shrink it until it's 1 unit long. And this is going to be, random.InsideUnitCircle.normalized is basically random.onUnitCircle. Somewhere on that 1 unit radius. So now when we multiply it, 1 times anything is anything. So it will always be at this speed. So I'll start with 10, I guess. I don't know. Nice. So there's one more problem that we need to check for, which is that the ball could get launched sideways, which is bad. So how do we fix that? Well, we need to test if it's going sideways, that means its x value is, its left and right value is large, but it means its y value is 0. So we just need to check if its y value isn't some very small number. We have to make sure we have a certain size to the y value. And if we make sure that is like a minimum value, then we'll be okay. So we just need to check if random direction.y is smaller than some small number. I don't really know what that small number should be. I don't know what those minimum angles are, but we can test those out. Except if the ball's moving upwards, then it will be, a positive number. So having a negative 0.5 or 0.05 could be a small upwards number. But if it's moving downward, moving straight down at our paddle, maybe, my value here might be -1, but that's still going to be less than 0.1. So I don't want its y value. I want the absolute value. Ooh, bringing you back to math class. mathf.abs. And that will basically force this to be positive. And so now the absolute y value of that will be if it is small or not. And if it is small, whoops, another parentheses in there, I think. Don't I? No, I needed one fewer parentheses. Thinking is hard, right? Whatever. Now I need to just give it some more y value, but if I do so, it'll make it a little bit too fast. So I'm going to just reset it. I'm just gonna change it. Just try again. And then I have a very fun piece of code here, which is if I change this if to a while, it will just keep trying random numbers until it finds one where it doesn't have a very small y value. And that's dangerous and a little bit janky code. And if we write this the wrong way, if we write this, if I accidentally do less than -1, well, the absolute value will never be less than -1. So I'll have an infinite loop and it will just try over and over again forever. And that's bad. Generally, our Unity will crash. Well, it won't crash. It'll just keep trying this until it well, okay, yeah, it'll crash. But you know, maybe it's fine. Maybe while loops are great, and I should be teaching them to you. This to me is one of the simplest ways to solve the problem, and I want this video to be simple. Because my gut instinct is to use a dot product. What's that? Don't care. Okay, so we got the ball. It's firing in a random direction on start. We got the paddle. We can move left and right. The ball's bouncing off of things. It goes down below and it floats into the void. And we just need to break some bricks. So I need a brick. Brick. And I need a box collider. I don't need a rigid body on this one. But let's make a new script that's going to handle brick collision. Brick. Because bricks should be responsible for themselves. The ball could hit something. It could have an on-collision enter, and it could say, ah, yes, I hit you, you should die. But we just want the brick to handle itself. Because it's probably going to have some more complicated code. It's going to have a score, or a brick we need to hit multiple times, or animations, and particle systems, and sounds, and that's a lot of logic, and I want the brick to handle brick, and I want the ball to handle ball, and that's it. So we are going to use the onCollisionEnter2D function, which will tell us when a collision happens, and let's just test it. Hit. What we hit. And let's just see if we even get this thing to run. So let's take our console and drag it out. I don't trust looking at the warnings down here. I want to see them in my console. And I will remember to add brick to my object, and I'll duplicate it a few times. So I'm not just here testing it forever, waiting for it to hit the brick. I am. Let's try again. Oops. Okay, we did hit the ball. Great. So what we were trying to test there was, if I don't have a rigid body, will this collision still work? And as long as one of the objects in the collision has a rigid body, the onCollisionEnter function for both objects will get called, which is exactly what I want. Let's delete those extra ones, extra bricks. We're going to make a prefab later. And what should the brick do when we hit it? Well, it should destroy itself, should delete itself. So I'm going to write destroy game object. That's it. But let's be a little bit clever about it. Let's move that to its own function. So collision detection and destroying itself. Maybe we want to animate it out or play a sound. Some more logic in destroying. Let's separate these two things, even though the destroy function is just one line for now. Delete brick. And now it'll be very easy we know exactly where we should be adding sound effects and things. Because the other question is, do we need to test if we're going to hit anything other than the ball? Will we ever hit anything that is not the ball that we should test to be sure? And I think my gut is like, yes. Because if things overlap, or if I have some kind of power up, I don't know. I mean, my gut is yes, right? So let's use a tag on the ball. And let's go ahead into our tags and layers and add a tag and call it ball. Let's go to the ball and let's add the tag. Just because we use this menu to open up the tags and layers settings, it didn't actually add it. We got to go back and change it. And then let's just test if the thing we hit has the tag ball. If collider dot game object, sorry, not collider. Well, yeah, the collision dot game object. The other thing we hit, if its game object has a compare tag, then we will delete brick. I kind of want to rename this function. I want to call it that, because we might have some special bricks that like have to get hit more than once. This one doesn't. This one just gets destroyed. But maybe it's decrementing a counter before it actually deletes the brick. Okay. Let's test that it still works. Amazing. We have Brick Breaker. We have everything we need to make Brick Breaker, except the ball goes off the edge of the screen, and then it's gone. So let's add that last little feature. So we're just going to make another 2D sprite square, and we're going to, put it there. And we're going to give it a box collider just like we did, but this time this is going to be a trigger. And we don't actually need that sprite render. I just like to visually edit, and see how big it's going to be. So we can just disable that. Or like color it red or something. Whatever. And then the ball is going to detect when it goes into a trigger zone. And we're going to use the on trigger enter 2D function. This one gives us a collider 2D, not a collision 2D. And just be sure using that 2D function. And here we will just destroy the ball game object. And that's all we need to do. I just don't want the balls flying off the edge of the screen and going forever and ever and ever. For now, we'll just destroy it. And then that's game over. So no more ball in the hierarchy, just heading off into the ether. And now we have our game. I think I probably wanted to use collision layers and not tags for that check, but it's fine. Okay, well, we'll leave that there for now. We probably would want to do a check for the object, or do you want to set the layers up such that this would only ever, happen with the ball, and if there's some other trigger zone, like a power up, pick up the ball wants to overlap, or a wind zone, or some other way we might want to use triggers. We might want to check that against a tag or a layer, or something of some sort, or have the code be on the death zone to be like, oh, a ball hit me, destroy that ball. But none of that really matters right now. It's, we can add those features when we need them. We don't need to overcomplicate things just yet. I don't plan on adding any of the power-ups or whatever. So, but things to keep in mind. Anyway, so that's the end of part 1. Just a brief, breezy 45 minutes of making a couple balls bounce around a screen. But in the next part, we will add the game manager and, make it play. Because the ball, the game ends. It's not a very fun game so far. I have 1 brick to destroy, and I don't know when the game, when the last brick is destroyed. I can't win. There's no win state. And then when the ball gets destroyed, that's it.